I think I can even start. So we're going to be talking about code reviews. That's why you're here. That's what I said in my description. I hope I can deliver up to the standards of such a big room. Quite honored to be here. My name is Paco from Beckhoven. I'm a senior software engineer at a company called Hexagon, which is quite big. I work on the division which is called Geosystems, on the business unit called HXDR, which is all mostly a big corporate company. The platform, however, that I work on is quite interesting. It's a cloud-based platform that allows people to explore large 3D models, 3D scans. We're building 3D scanners. We do all kinds of awesome things with 3D, and that's just a part of the things we do. It's also very not relevant for the rest of this presentation, but at least they were nice enough to sponsor me to get here and to pay for my time. There's something new here. There's this giant QR code that will also be at the very end of my presentation. It's something I stole from another presenter called Francois Martin. And it leads you to the landing page. There's the social media and everything. And there's also a way to sign up with your email address. And then you get at the end after the conference, you get an email with the link to the recording. And there's a chance to then reply and give any feedback if you still have some after that time. The reason why I'm here is that I really like code quality. I like talking about code quality. That's why I go to different conferences. I really like developer experience. That's why I want to share things about my learnings about code reviews with you. Now, that's enough about me for now. It's already 2 minutes. Let's talk business. So $316 billion. That is unfortunately not my salary. Would have been nice. Could have solved a lot of world problems with that. No, it's the estimated cost of finding and fixing bugs in 2013, according to research done by Cambridge University. Well, you can imagine 2013, 2025 now, so that number has tremendously increased probably with inflation and all, which is a lot, right? We should be able to do a bit less. Now, we know is that the cost of fixing a bug increases the further we find it in the development phase. If we find it during requirements time, it's easy. We can fix it at no cost. But if we find it in production after a year, we need to investigate, we need to figure it out. We have the reputation that's lost, it costs a lot of time. Now, what we can do is, of course, try to find them early through code reviews, which we do approximately in the coding and testing phase. There's, of course, many other things you can do. We can also just not write bugs, but not that easy typically. Now, what is a code review? A code review is, because it's basically 3 important parts. We want to be able to identify errors, right? Not find the bugs early, but there's actually more. Code reviews can also be used to foster learning. It's a way to learn about the changes that are going on, to teach new employees about the current standards that we have, to learn from each other, to teach the junior about new technologies, mentorship. And it's also about improving the code quality. And because I like code quality, I thought I'll add an extra definition to that as well. It's really about making it more readable, efficient, and also in line with your team or your company's standards, best practices, which all sounds pretty good, right? Yes, code reviews, yay. Ta-da. No, I did add a small disclaimer at the end, also after some comments. Of course, there's nuances to this. You can heavily invest in pair or mob programming, where you already spend a lot of time upfront to prevent, as a team, to sort of try to find as many mistakes as possible early on, or you have a very mature and senior team, which is already still so sort of efficient that you could argue maybe we don't need code reviews. I still think it's always a good thing. It's always good to have multiple eyes on the changes. You can always forget things. Now the question is, of course, how can we efficiently incorporate code reviews in our development process? And there's, of course, an obvious one, right? That's where pull requests are invented for. So I want to do a quick show of hands. Is it called a pull request or a merge request? So pull request? Merge request? Right, so those are the GitLab users. I myself too am now a GitLab user, which means my team indoctrinated and forced me to adopt the term merge request. To me, they all mean the same thing, but if you see me mixing them up in this presentation, don't worry, I'll still try to use pull requests as the sole thing. Now these pull requests are facilitated by most version control systems. You already see the really nice one over there, but there's more. And they're great. They allow us to add comments. They offer a lot of nice integrations with the build tools, but also with other tools that can already add comments up front, do some quality checks. And even though we have these great tools, we often still see the less pretty sides. And that can be the massive pull request that was opened that changed half of the project with the very elaborate title and description, which also often looks good to me in 30 minutes, surprisingly. But there's also the great feedback we receive, the fact that we sometimes have to wait a bit longer than expected to get our reviews in, and last but not least, of course, the curse of the small pull request, which we've all been there. It's much easier to argue about 10 lines of code than it is to argue about some complex change and trying to understand it. Now, how do we address these issues? And one part of the solution lies in creating good review-friendly pull requests. And for this, we're going to sort of skip the development phase. We're going to assume that all our changes are concise, focused, and tested. However, as due recent developments in my own team, I want to emphasize on concise a bit more. So there was a situation where we designed a feature. We split up the work in small tasks, which would all take about 1 to 3 days, separately, nice incremental parts. All great. And then 1 week later, a big pull request emerges that covered like half of the tasks in one go. And I got a bit frustrated, so that ended up in a discussion. And I got this argument. I don't want to do the extra work because there's a lot of overhead with creating separate pull requests. This works, let's be pragmatic. Start with communicating that you're going to do all the work at once. But hey, you can imagine that I was a tad frustrated. Though after taking everything in it some time, not responding immediately, I did realize the point, right? It is indeed for the developer, it was more work to split up to create separate MRs. And for him, yes, for sure, it was more work. But the whole point of doing this is you do an investment that you do for the rest of the team to improve the quality overall. Because so I asked ChatGPT, can you help me with coming up with arguments on why we should split up our work? There were plenty. So many that I think I don't really need to continue this argument, but I want to emphasize that because I got the point, right? It was more work for him, and especially if he would have picked up all the tasks anyway, still, for the whole bigger picture, it's much better to still split up the tasks, invest a bit of work. Now, to have that out of the way, another one, there's a nice quote from Uncle Bob. It's of course about writing code, but I think this applies to more, also to pull requests, right? Whenever we create a pull request, when we write it, there will be multiple people reviewing it. Of course, it won't be reviewed until eternity. At some point, it's merged, and then the chance that we look at it are still there, right? Because we sometimes go back in time to see why did we do this again, or what happened here. But of course, not so far. The point is still being that it's good to invest a bit more time in making sure that we write it nicely, because it will be read many times. Now, I'm going to start with the actual pull request, which starts with a good title, which is not what this is. We want to start with adding the right amount of context. We want to elaborate what's going on. So in this case, adding a bit more context, when does this bug happen? Where does it happen? It's immediately clear from this title what's going in the pull request. You could argue that's maybe a bit long, but still, it's a nice title. What you could also say is that a good title should be like a commit message. It should be very self-explanatory. And we can also apply that case here. There's this thing called conventional commits. Just check it out. It's a great way to sort of standardize the way you format your commit messages. And you can actually also apply this to your pull request titles, because often, especially if you, for example, set up squash commits, the title becomes the commit message. So it would be nice that it also adheres to the same quality standards. It also allows you, and you can force this with a linter, that you always have the ticket number in there. So that's also great, because if the ticket number is in there, it's clickable. We can get straight the context from the Jira ticket or any other ticketing tool, but mostly Jira probably. You can add majority, like if it's a small fix or a feature, and then automatically do versioning based on the pull request title. It offers you a lot of things, good things. And then there's the description. We can put a lot of things in the description, and I think we should start with adding some context, describing what was going on, what's the feature that we're building, link all the related other pull requests. For example, if you also have a library somewhere that you're upgrading or updating in relation to the change you make, link them so that it's clear that these are together, or documentation or tickets. Then we want to give a quick overview of what the user can expect. So what has changed in this pull request? Is it just the code, or maybe you did some extra things? Maybe you did a small refactoring there so that they know what they can expect. And then the why. And with the why, I typically mean, why did you make certain decisions? Why did you make certain changes? Because when you write your changes, you go through some thought processes. You try out maybe different things. You experiment a bit here. That is still in your head when you create this pull request, but typically, at least for me, after the weekend, that is gone. So write down sort of all the things you went through, not all the things you went through, but try to highlight some of the parts of things you tried out, just so that the reviewer also knows and they don't even need to ask about it. Then examples. Examples are great. For front-end work, this is, of course, very easy, right? You add some screenshots of whatever you're doing. But for the backend, there's also many things we can put down. If we add a new endpoint, add some example requests and response, so that and not screenshots, actual text, so that people can copy it and try it out themselves. They can play with the endpoint, which allows them to test them and already find some issues early, maybe. And you can also do this for database changes. You can add screenshots of the screenshots. You can add some example queries on how this would work now. There's many things you can put in there. Now, the challenge still remains to keep this concise and readable, because nobody will read the big wall of text, or at least they will struggle with it. This is where tools like ChatGPT can help you to sort of structure it, but what also really helps is templates. I really like templates because they help us in sort of where to put the right information, so that our brain also knows immediately where to look to find the right information. What I specifically like about templates is checklists. As I mentioned, I tend to forget a lot of things after the weekend. And there's also many things that only need to be done every now and then. For example, if you have some architecture documentation that needs to be updated when you introduce a dependency on a new service. This is something that only happens maybe 1 every 10 or 20 pull requests, because with refactoring it's not that relevant. So it's still good to have a reminder in there that you still need to check and see, okay, right, this still needs to be happen. Only recently we have a service in which we define pipelines, and this often requires some extra work and documentation in other places. And just having this checklist there has already helped me and others many times. Right, we always forgot the documentation. Now, what's the way to enforce this? Adding it to a checklist in your pull request. But tailor this to your organization needs. Maybe there's some quality checks that always need to be done. Put them in there so that you don't forget. And you can enforce in most tools that all the checks need to be checked before you can merge. Decide this works for your company. Now, having created the pull request, we're also going to start reviewing it. We're going to be the first reviewer. The reason why is that when you look at your code after you finished it, maybe after a good night of sleep, when you look at the diff, you have a different perspective, like diff. For example, you made changes to a file that actually were not needed. You didn't need anything in that file. There's probably still only just 2 line breaks there. You might want to revert that because it just clutters the big pull request that adds another file. But there's more things in there. Maybe you missed some names that don't make sense. Maybe there's still some comments that have typos. I often manage to capture quite a lot of things if I just go over my changes a second time. Things that need to be reverted, need to be tested. And what also is really nice, so we also want to start commenting on our own pull requests to add some context where possible. And one of the things, for example, what I did, I was making some changes, and I came across a test file that turned out to be not used. As curious as I am, of course, did try to figure out why is this unused and who should have removed it. Now, the blameless part is, of course, good. Don't go into blaming, but it's still good to write down the research. Right? Hey, you investigated this, write it down there, so that whoever's reviewing it also doesn't have to go in the code, try to figure out when is it really unused. It's immediately there that you did the research, and it can also be adding context to maybe you did some renaming here, or to clarify why you removed some changes, so that maybe not be clear from the diff itself. That's what I try to do, is to go over the diff and see, okay, does this make sense? Always think about the review, what kind of questions can I expect? Maybe I can already answer them here. It's only fair, it makes it easier to review. Just you can also highlight the important parts. So say your formatting settings within your team are not great. You're trying to fix a bug, which is a 1-line change. And now you also formatted the file, now it's a 20-line change. So in those 20 lines, one is the bug fix. Why not just add a small comment to that bug fix, like, hey, to that 1 line, this is the important part where we fixed the bug. This is the core of the change. The same for the tests. Maybe you did a lot of changes, but this is the important part. And you can also ask it the questions. Maybe there's parts of the change you introduce you're not sure of. Maybe you don't like the name. You can sort of already start the conversation with the reviewers by asking them, hey, what do you think? Can we improve this? Should we do this? Or ask another team. Maybe you're integrating with a new team, with a different team. You're using their API. Hey, we're using your API here. Is this the way to use it? Now, having reviewed it, we're going to need the reviewers to look at it. And in an ideal world, we don't have to ask for reviews. People proactively check if there's any open pull requests, and they start looking into it, or they automatically assigned, and we actively look at the things we're assigned to in practice. Yeah, it takes people away from their current task. It maybe doesn't contribute to the things they have to do, switching context. Maybe they think, this is such a 10x engineer, I'm not going to find anything, so why bother even reviewing them? Now, sending a picture like this every time or a meme, at some point you will run out of them, and this will not work. Throwing it in a big channel with 20 to 30 people or more. And why this doesn't work is typically what we call diffusion of responsibility or shared responsibility. No responsibility, we're all sort of expecting somebody else to pick it up because we already did it like 2 times this week. Yeah, that's not very effective. What does help to sort of tackle this diffusion of responsibility is to always target specific people. And this doesn't, if you don't know who's the right person, just tag one. And because they're most likely, if they're not the right person, very quickly into redirecting you to the right person. I'm also adding some context, so not just dropping the link there, but say quickly, okay, this is a small or medium, or maybe something about the size, what they can expect, but also in which area this pull request, which feature is it? So because maybe somebody else is working in that same service or that same feature, and then they now know, all right, this is in the same area, I can either expect some merge conflicts here, I should quickly look into this, or there's a small one, I can do it right between these 2 tasks. It quickly helps there. It's a small thing that might help a bit, and also adding some sense of urgency, whether it's something that can wait, it's a refactoring that has no urgency, or something that is blocking other work. So a message like this is more likely to get faster traction than just dumping a link in a channel. And actually, this goes further than just asking for reviews, but basically whenever you need anything from any team. There's a team channel and you need some statistics on their endpoint, or you have some questions about their services. It can happen that you drop in a question and that they're all busy and thinking, somebody else will pick it up and then it will take 3 days. But if you just tag a person, you might get a much quicker response. Now, people start looking at it and we have to deal with the feedback that we receive, which is also not always up to standards. Some people simply lack the social skills, but there also might be cultural differences at play. So I'm from the Netherlands. We're known to be quite direct, which is not always appreciated. So what could help me with just this knowledge is maybe I need to add a bit more fluff to make it a bit more nicer. I think my main point here is that even though we have issues like communication styles, don't take it personal. In the end, we're all on the same project, and being a professional is also about being patient and being the bigger person, and don't let these frustrations overcome you. It can happen. Don't start a fight about the tone of voice. But there's more. You can also receive some vague feedback, like, hey, can you please improve this? Now, what is this, and how can I improve it? You can go through some trial and error, trying to figure out what they meant. I've been there, and I've done that, and I spent like 10 times rereading the same command. Could it be this? No. Could it be that? No. This is a waste of time. It's much easier to just ask for clarification, because there's also, if there's multiple interpretations possible, there's a chance you're wrong, and you're even wasting time. Don't waste it, just ask for clarification. Then, and I think we're all familiar, and we've all been there, when one person has an opinion and another person also has a strong opinion, you sometimes get into a fight. Well, let's call it a fight, let's call it a discussion. Of course, as always, pick your battles. You don't have to be very strict on everything, but if you both think this is the battle you need to pick, and you're at your 7th or 8th comment and things start to get heated, maybe it's good to just take it offline. Also, because these discussions in pull requests often means that there's like half an hour and then another person replies half an hour later, so you're constantly switching, and it's not efficient anymore. What is important if you take it offline is to always come back and report what was decided. And this also goes beyond just discussions in pull requests. This of course goes to any Slack conversation you have. We've been there, that we look into the past, we look for this exception, we found this thread, you see 2 people that were sort of having a conversation and then it ends. Always report back. We decided it can be a quick message, but it's so helpful for future you. Now, last but not least, you will also learn a lot of things, right? In the end, the people that are reviewing are not there to personally bash on you, but they want a nice and a good solution, and in the end, you should also be wanting a nice and good solution. And you'll learn things, right? Maybe you've missed things, but also maybe there's some framework you didn't know about, or some way of invoking methods that actually are quite good. So try to show some appreciation, especially if you have people new in the project, some juniors that now started reviewing. They're finally putting their new comments down, and just showing some extra appreciation might help boost their confidence a bit and make them more willing to do more reviews and be more confident about it. Now we're going to switch seats. So we have just received the review. Now we're going to be giving reviews. And I think the important part here is to always review in a timely manner. The longer it takes, the more time you will lose over time on context switching, but also the more chance you will get that there will be merge conflicts. And what can help here, at least what helps me, is to always start the day with reviews, because you don't have to switch any context if you're new, right? If your day just started, you typically don't have the context of all the work. Do some reviews. Spend the first hour of your day doing reviews, and then the rest of the day you can focus on the work, and then or whenever you're switching tasks. So there was an interesting take that I got from another conference where somebody said, ideally, your backlog is prioritized, right? So all the tasks at the top are more important than the ones at the bottom. So whatever has been picked up, which should be from the top, is more important than whatever task you're going to pick up. So whenever you're going to pick up a new task, make sure that the existing work has been reviewed before you start picking up a new task, which is, I think, fair reasoning. So that might also be a great moment to start reviewing. Now, the other thing, and this is again maybe coming from personal frustration, it's really about taking responsibility. It's not to unblock somebody because they can only merge if they have two approvals, so they need an approval to merge. It's about taking responsibility. To me, I think a review should be like a sign-off. You put your name, sort of like your signature at the end with, I take full responsibility of all the changes in this pull request, I understand what's going on, and if anything happens, I'm also to blame. Which may be a bit extreme, but you cannot review something you don't understand. So you have to put in the effort to actually understand it. No, don't just think, yeah, looks good, I looked at the style. Put in the effort and think of it as you're also the responsible. At least that's the mindset I keep, and that helps me into not getting lazy and taking shortcuts. Now, when you start reviewing, start with getting the context. We just put at the beginning of the presentation, put in a lot of effort into writing this elaborate description. We reviewed our own work, we added comments. And it's a bit of a shame that somebody comes in, and even though I'll admit I've been there, I went into the code straight away, and then I started wondering, what? Why? And then halfway writing the comment, I was like, wait, first check the description, and then often, luckily there was actually an explanation in the description or an existing command. So don't make that mistake and just first read the description. Also check the existing commands, because it's really annoying to have the same discussion in multiple places. Then, where do we start typically, right? We have this whole set of changes. How do we approach it? The best, so I got this from, I think, a Google guide on code reviews, and they had some fair points, is that always start from the top. Start from the design, because any comments you have there will have a trickle-down effect on, say, the implementation. If it turns out that a part of the code needs to be rewritten, then it doesn't make sense to start commenting on the code style of that class if the class needs to be maybe removed anyway. So start from the top. Is the functionality in the right place? And then is it implemented correctly? Did we miss any certain use cases or certain scenarios? Then we kind of looking at the complexity, right? Can this be done is it done efficiently, or can we do it in a different way? And then we start looking at the tests. And I made tests bold because what we often see is that tests are sort of the second half of the pull request. Alphabetically sorted, you first get all the source files, and then you end up with all the test files. And typically this is the point where people sometimes think, yeah, it's just a test. They passed, it's fine. Also because it's the second half and you already spent quite some time reviewing the first bit. They get the least amount of love and attention during implementation as well, often. And if you also have that during review, you might end up with a bad test suite. And that bad test suite will affect you, and it has affected me many times as well, where I thought I can fix this, I can rely on the tests, and then it turns out that some assertions were missing because the person only asserted that one thing that was done in this change instead of the whole object. And yeah, I missed it, and then we have a bug, and I need to go back and fix it. If we had proper tests, it wouldn't be an issue. So make sure you check the assertions. Are they complete? Are we asserting the right thing? And also the test code can often get a bit of love. And then at the very end, we can start nitpicking. We can start talking about the code style and specific, like, hey, should you not use this or that? Or, hey, there's a typo here. It should be A instead of N. Which is still fair comments, but those are for the last part. Now, there's tools available to help us with this. Like I mentioned before, those version control systems like GitLab, for example, allow you to get inline code coverage. Doesn't work, but it's okay. The top one. Who here uses code coverage in their diffs in merge requests so that you get the green lines in the diff when reviewing? Right, it's a couple of them. If you have a chance, please investigate how to do it because it's so helpful. Ideally, right, all the code we introduce should be tested, which means if we want to verify this, we either have to go over the test code and see if all the scenarios are covered, but we might miss things, or we have to actually download the coverage report, go through the coverage report, put it next to the changes, and then compare, which most likely we're also not going to do. This helped me often. I've had cases where I managed to find, assuming here that the reviewer, who should be the person who wrote the code, should be the first reviewer, I often spotted things like that code that wasn't reached in this pull request because it wasn't tested. When I asked why wasn't this tested, it turned out it was that code. Wrong order, but still the same code. So it's easily to also spot code that can just be removed. There's also tools like Sonar that can integrate and already add some comments, so at least you can skip the first bit. Now there's one tool, because not everybody's able to, for example, set this up in GitLab. It's really easy to get the code coverage to work. Your editor. Your editor is the tool we all have and we can all use, and it's a really great tool to help us review. So, for example, take this change. Don't think too much about it, but it's a change, and the idea is, of course, to trick you. Because it looks sort of okay in this context that we see it in the in GitLab. But if we then open our editor and look at it, we immediately start seeing some things that are wrong, right? This constant is now unused because, hey, here, you remember here, the content at the top, we aren't using the constant anymore, so, hey, why is it still there? We should remove it. But it wasn't visible on the left side, right? We needed to expand. And also, your tool, your VGS tool like GitLab won't tell you that this line is unused now. There are some minor optimizations possible, right? Here, IntelliJ will tell you you can use isEmpty. But also, you can always, in your editor, run the tests with coverage. And then you get this here, and then you can also see that this specific line is not tested. So the editor is a great tool. I always try to first quickly do the great overview of the design and everything from the GitLab, and then I dive into the editor at least once and go over all the change sets. You have a nice F7 button in the diff, and you can just go over all the changes and quickly see if anything, your editor even helps you to review it. Now we're going to find things. And sometimes there's some challenges in writing a good command. I think one of the issues that I've seen, or that I learned about, is the use of the word you. You chose the wrong framework, use X is actively maintained. You can be interpreted as a direct attack. I'm talking like you did something wrong. This doesn't sound very friendly, and this makes people more defensive and less likely to cooperate, so you probably just end up in an argument. Whereas we is about collective ownership, and we are all in this together. And it might not be in the literal sense that we made these changes together, but we are in this as a team. The individual is not that important here, we. I'm going to get to the example later. Then there's also the statements, right? You chose the wrong framework, which is a bold statement, which of course can also be easily falsified if it turns out that I had a perfectly fine explanation for it. Now it makes you look like an ass, in my opinion. So again, if you make a bold statement, people are less willing to cooperate. Whereas if you turn it around and turn it into a question, you have a chance that people will come to the insight themselves, right? Why did you choose Y? And then they're thinking, right, you have a good point there. So if somebody comes to the same conclusion triggered by your question, it's much more helpful because then much more willing to also change it. And it all sounds much more friendly. And I think friendliness really helps in these pull requests, the tone of voice. Then there's also try to be specific. We had the vague comments, right? Try to stay away from words like this or that. Always reread and try to figure out if there's multiple interpretations possible, because this often refers to something in your last line or maybe something in the code you selected which was not clear. Try to be explicit. Always reread your comments, see if there's multiple interpretations possible, and also try to provide an alternative solution. It's easy to say, yeah, this is suboptimal. It shows some. It's much nicer to also try to think along and show that you're also willing to help. And also because it's really easy to say something is wrong, but it's really hard to also come up with a suggestion for, say, a good name. Now, another thing that's great about these tools, suggestions. Who here uses these suggestions in your VCS tool? Yes, nice. That's already a nice amount of hands. It's great for so many reasons. The first one is that you immediately make clear what is being changed. There's not multiple interpretations possible. If somebody clicks that apply button, that means that they don't have to go into the code base and actually fix it. And you don't have to go back to the pull request to see if this was actually properly fixed, because it was fixed as you suggested. It's, to me, I really love it. There are, of course, there's a caveat. That means that if you suggest a different name for something, of course, it's a stupid change, right? It's not going to rename all the other places or remove the imports. So you might want to add a hint, oh, don't forget to rename it or remove the imports. It's not a fix for all, but at least it makes the intent very clear. There's also this thing, and I personally think it's maybe a bit extreme, but besides conventional commits, we also have something called conventional commands. And it's about standardizing the way we place commands. And yes, it's a bit much. I had fun, tried to play around with it. I learned some things about how to sort of structure your commands in a more clear way. The most important takeaway from this is, I think, the nitpick label that we see here. To make clear that this command is not urgent or important. You can, as a team, come to an agreement that if something is a nitpick, it's up for the person who makes a change to decide if they're actually going to do something with it or not. It's a non-blocking command. It doesn't have to be fixed. It would be nice if it would be fixed, but I'm not going to start a battle over it. It helps. It makes, again, it saves you from discussions on this part. If the person who makes a change doesn't agree with it, fine, then don't. It's not the end of the world. But what is important, pull requests are often a negative place, where you mostly hear what you did wrong and what you could have improved. And I had a laugh when looking at this as well. Try to find some positive things. Force yourself to find at least one positive aspect in a pull request, because there's always something that is done right. Not everything is done wrong. Maybe something they did in a super fast managed to fix this thing. You can compliment them on that. Maybe it was a really nice elaborate test set was introduced. Finally, this refactoring of that awful component that's now finally improved. There's countless of positive things. Try to practice with it to finding them. Maybe they did some cleanup here and there. Show appreciation, because that's great. It adds a layer of friendliness, of course, to the pull request, right? Instead of just hearing what you did wrong, you also hear a bit what you did right, which is great. And it also helps you boost a bit of confidence, especially what we see in a time where there's a lot of imposter syndrome. We're all not that great because everybody's better. It helps you boost your confidence, and it all comes down to things being more positive, more friendly. And as we've seen in the keynote, a friendly and happy team is more productive than an unhappy, violent team. So we've covered the pull request part, the first bit, but I have time, a lot, I think. Yes, how much time do we have? 60 minutes, great. There's this other part that I wanted to address, which is called bike shedding. Very Dutch common thing, right? You have your shed where you put your bikes in. No, it's bike shedding, also known as the law of triviality, is based on the fact that we rather discuss the simple bits, like the curse of the small pull request, than trying to comprehend the complex parts. The title comes more or less from a sort of a design committee that had spent much more time discussing the bike shed of their office than this complex nuclear power plant they were supposed to discuss. Of course, it's hypothetical, but that's the idea behind it. And we often do the same thing in our pull requests as well, right? We rather find it much easier to comment about the little things like the code style, like, right, you should use this empty there instead of equals, which is, I would say, I wrote it there and there, so this is already a bit wasteful. And having to comment on these things, these are trivial issues. And all these trivial issues add a lot of noise to the bigger picture. So what I want to quickly go over is a set of tools, right? I don't have the time to demo them. At the end in the conclusion, I will also have the links to the tools, so you don't need to have them all, but I want to go over them and see how they can contribute. And the first tool for me is error-prone. For those who don't know error-prone, it's a static analysis tool to catch typical programming mistakes, which you may have also seen with checkstyle. But the difference is that it also suggests, and Sonar also does it, it suggests and provides automated fixes. Then there's also, I added Picnic here as well. Error-prone is created by Google, and it creates sort of a set of rules on how to write things, so that there's only one way. Picnic expanded this set with a whole lot of more rules, also very biased, of course, on their way of working and their frameworks, but it can help. And now what does this look like? For example, here, we have a list. We can filter that list. We don't want the null values in there. Now, there's two ways to do this. We can do this with the address isn't null check, or as it's suggested here, Picnic really likes to use objects non-null, because it's maybe easier to read. So rather than having discussions in all the different teams over the company, they just said, we have this rule. If it's not done this way, we fill the build. But we can automatically patch it for you, because did you mean is actually automatic. If you use the patch command with errprone, it's automatically fixed. Same for big decimal value of 0. You can also write big decimal 0. But it also can actually find quite some issues. What I found when going through my code base, or when we introduced this, the confusion between string formatting and logging formatting, the way the placeholders work. So this is broken because the curly braces is what you have with logging frameworks, whereas you use percentage sign and then the S for string formatting. Great, now I got an error, because typically we find these things somewhere in exceptions where we don't expect them, and it doesn't happen often. Then another one, does anybody know what's wrong here? Sorry? No, so I didn't fully hear it, but I'm just going to spoil it. This doesn't do anything, actually. So there's the assert that. If you don't put anything behind an assert that, it does nothing. It needs to have is equal to something, or is true in this case. If you wanted this to make it work, it needed dot is true at the end. Of course, then you could argue, right, you should say assert that some.get id dot is equal to this thing, right? That's even better. But this was a bug that we had in our code base. These were assertions we had. This is awful. And it's really hard to spot them when you do a review, because you don't expect this. You see assert, or you see equals. That should be fine. My brain accepts this. Now there's more. You can improve the readability. So here we have, with Spring, you have the request mapping, but you can also replace this with add post mapping. Then you get rid of one line. I mean, it's something that would either cause maybe a discussion in a pull request. It's a command that you write, so somebody has to come back to the code base and do it again. One of the things that I recently, because they keep on adding new rules, one of them is if you do an instance of check, you don't have to cast it again if you name the variable. So if A instance of B and then the name of that thing, you don't need to cast it anymore. I came across this in a pull request, and I was writing a command, and in the meantime I was also actually upgrading our errprone library, and I saw, hey, this thing fails if this happens. So if the compiler fails on this wrong usage, right? If they're still casting after an instance of check, which you don't need to, I don't need to write the comment. The person doesn't have to go back into the code base and fix it. So it's much easier to fill it and compile them, and they probably will learn after 2 failures. So when you introduce errprone, there's a lot of rules. Test the rules in your code base and choose those that match your team style best. Not all will fit. Not all will fit your frameworks that you use. I know some are very opinionated onto using Guava or not using Guava, or using immutables. You can disable those rules. You can also make them fail, make them more error, make them automatically fixed. The nice thing about the fact that it can automatically patch them is that it's easy to introduce it to your code base. So when I'm updating these rule sets, we typically define them in a parent POM. I go over all the projects and run the patch command. Now, often I do have to format the code afterwards again. But then immediately your code base is in a good state, and from here you can start failing on newly introduced errors. Another tool, Open Rewrite. Who here has used Open Rewrite before? Great. Who has migrated from JUnit 4 to JUnit 5? See, so these hands don't match. Open Rewrite is a great tool that allows you to do migrations in your code base. Especially JUnit 4 to JUnit 5 is one that's very painful, and you have to do it all over the place. You just run one command, you select the right recipes, you run it, it's done. It's also the tool that's used by Spring. In their documentation, they have a whole set of upgrades, recipes that automatically do most of the work in upgrading to the latest Spring version. It's also really helpful. But even things like if you want to move from JUnit to assert J, in terms of Hemcrest to assert J and assertion style, there's recipes for this. There's so many recipes if you want to move to the latest Java version to automatically upgrade your code. Why is this useful for merge requests? For example, if you finally decide to go to the latest Java version, you will get like, it's going to be a gradual migration. Hey, this switch statement, you touch the switch statement. Can you also improve it to the new style? If you just do it in once, then you don't need to be bothered about it in pull requests. You can also even run the recipes and then make your build fail if there's a diff after running the Open Rewrite command. So please check this tool out. It's amazing. It's free. If you want to pay for it, that's only if you do it on a large scale. So it's really easy to use. Another thing that often causes a lot of noise is formatting, right? If we have different formatting settings in the team, in the project, within the team, it's awful, right? If one person formats the file and another person has a different format, I would say this is the worst case scenario because it just adds a lot of noise. So the more opinionated your formatter is, the less room there's for discussion, except when you're introducing it, then you get all the discussion. But afterwards, once you've gone through the pain, it's fine. I'll get back to that part as well. Make sure that whatever code style you use can be automatically enforced, because otherwise you keep, what I was always doing was, when I was new to the company, I opened the pull request, or checked it out locally, formatted all the changed files, cut a list of changed files, pasted that back in the merge request, pull request, can you please format these files? Which is a waste of time, right? It's 3 minutes, or no, I mean, I was quick, maybe 1 minute, every pull request, and brain capacity wasted if it's just automatically enforced. One of the tools, if we talk about opinionated, is Google Java format. It's super opinionated. There's effectively, I think, 2 configuration settings, which is tabs or spaces, more or less. And that's you have to deal with it. And yes, that means that there will be scenarios in which it does format suboptimally, and where you think like, really? On the other hand, and also you will get the point when the pain when you introduced it. We all have that when we try to switch code styles, where you're like, I really don't like this. And then when we move to the next project, we're also again, I really don't like this. I really want the old one back. And we keep on going in these cycles. We just don't like change that much. But if you take the pain and then from there on it's consistent, you don't need to argue about it anymore. It's enforced. And this goes beyond Google Java format about Java. Your project often contains many different languages, more than just Java. There's probably some SQL in there, some YAML files, some XML files. Spotless is a great plugin for Maven that allows you to format all these things. So if you format Java, you actually have Google Java format already in there as an option to keep the consistent style in your project, so you don't have to be annoyed by it, because Spotless can fill your build if it's not formatted well. Then there's check style. We all know check style. It's great for indeed enforcing code style. So I was unfortunately not able to convince the whole team, maybe shouldn't have done it in the first month I joined, to switch to Google Java format. But at least we could agree on a set of rules that we could automatically enforce with check style. And another thing that you can do with check style is also do some enforcing on names. For example, if constants should all be uppercase, and it integrates with most errors, or that you always put your static variables at the top. Then there's one more, Arch Unit. Who here has used Arch Unit before? Nice. So Arch Unit is a framework that you can use in your unit test to sort of enforce architectural guidelines and naming conventions. It also forms the basis for Spring Modulith. And it's sort of a DSL that allows you to enforce package structure. One of the typically things, say you have this whole controller, service, and persistence layer, you always have the controller layer should never talk directly to the persistence layer. The persistence layer should definitely not talk to the controller layer, and ideally we always want this top-down view. So you can easily define this with these rules. You can define these rules in a central place and then import them on all your projects, and assuming that over your projects you sort of have a predefined package structure. This is a great way to enforce all these rules. And you might find that you're actually taking some shortcuts here and there. And this is actually great for spotting them. But what I also really like is that you can put all kinds of naming conventions in there. We typically have this interface story, right? Should you prefix it with an I? Should it postfix it with an interface? Should the implementation have impl at the end or not? Just pick one, stick to it, enforce it, and you don't have a discussion. You don't have to pay attention to the reviews anymore because it's done automatically. And it can even go further. You see here you have some rules in the controller, like if it's annotated with the controller annotation, it should have a postfix of the class name of controller. But you can also say if any of my methods is annotated with post mapping, it should also have an add secured annotation on it with enforcing the security rules. You have a lot of power here, and things that if you have custom rules, try to automate them. And for us, Archer was a great tool to sort of automate a lot of the guidelines we have. There's a large set of predefined rules actually that can help you. Try to use this to capture the common mistakes that you often see that you're talking about in the pull requests, and then have a shared module. Now, when you start introducing these tools to your organization, start small. Don't do them all at once. Don't do them in a big bang. Do them one by one, and make sure the team is involved. I really learned from this. create a sample pull request with, for example, for error-prone, whenever there's a new set of rules, I create a sample pull request where I activate the rules and some, like here, this is how it looks when applied, add some comments on the pull request. Okay, this refers to this rule, this refers to this rule, and then we can have a discussion in that pull request about the rules we like and we don't like. Because if you just enforce everything and maybe not everybody agrees on the rules, you might be the person that they always come to and complain about. Also make sure to centralize the configuration, so use a parent POM. Parent POMs are great to define, especially error-prone and checkstyle are very configuration-heavy in your POM file. You don't want to be copying this over and making changes all over the place. A parent POM is a great tool to put this and also all the other things that you have in your company to sort of centralize them. Now, to conclude, we're getting to the end. Write descriptive pull requests and also review them yourself. Spend some extra time on it. Be specific in your communication. Be friendly, try to find at least one positive thing in each pull request. The more the better. And use the features from your VCS to help you, and your editor as well, to help you review. Like getting the code coverage in the diffs is amazing. It helped me so much. And then, of course, to have a nice, catchy thing, stop bike shedding, start automating. Thank you. Right, there's the QR code if you want to sign up again. These are the links to all the tools I mentioned. Before you leave, please leave a rating. That helps me in trying to figure out if I did well or not. There's not a lot of options, unfortunately, in the app. Otherwise, you can send me an email if you scan the QR code. Which leaves me to 3 minutes for questions. So if anybody has a question, feel free to ask it. I see a question. Okay, yeah, so if I understand the question correctly, it's about if you have juniors in the team, they want to start reviewing, but they're a bit insecure if they come across as stupid or dumb asking questions. How can you sort of improve this situation, or how can you make this better, right? So one of the things that I mentioned before is compliment. Be grateful for the comments you retrieve. Hey, great question that you asked this. It's really about setting the mood for the team as well. So the seniors as well should be open to this. And if there's not, because often, and I've really seen this with juniors, they ask a question, hey, why did you do this? And you're like, yeah, actually, that's a very good question, but we've always been doing it like this, but it doesn't make sense. And just complimenting on them, even if maybe it's a wrong question, no questions are wrong, especially when it comes to juniors, that they can learn. It's, yeah, empowering, that's how I would say, just always compliment, be positive, and then they should get more confident and more involved. More questions? No questions? Okay, well then, thanks a lot for your time, for being here. I hope you liked it, and have a nice conference.